Assignment 4, radians and degrees. So first thing I want you to understand is that radians and degrees are just different ways of writing the exact same thing. So what I mean by that is if I said I walked 100 yards, right? Well, I could also say that in other ways. How many feet are in a yard? There's 3 feet per yard, so I could do 3 feet times 100, and it would say 300 feet. Now, these are two different things, but they equal the exact same amount of distance, so the same amount of distance. I could also divide, or I could do 300 times 12, which would give me 3,600. And if you don't believe me, 300 times 12 is 3,600. And that would be inches. Okay, so I could write 100 yards as 300 feet or 3,600 inches. They all mean the exact same thing. They're just written differently. So radians and degrees is a very similar idea. When we have degrees, let's say I have an angle that is 60 degrees. Well, I can rewrite this angle as a radian, and we're going to learn how to go back and forth. And also going to learn where a radian comes from first. That's what I want to focus on right now. So this is a unit circle. You've maybe seen this before in math classes, but you've probably never actually learned how to use it yet. So there's a lot going on here. We're going to start learning part of it. So so this is our first initial side right here. And you see 0. This is our x-axis. This is positive x, positive y, all in this area. This is where the unit circle starts. And so you can see a degree. This is 0 degrees. And then if you go all the way up here, a right angle, this is 90 degrees. And if you go all the way around, that's 180 degrees. And if you go or halfway around, I should say, is 180 degrees. If you go all the way around, we go back to here, which is 0, which is actually 360 degrees. So that's the degrees of a full circle. Well, a unit circle is a circle that has a radius of 1. So I have a blank circle here. So what a unit circle means is that my radius from here to here is 1 unit. Okay? Make that more obvious as a 1. Well, what that also means is that every line coming out of here, every single radius of my circle is the same. Which means if this is 1, these are all 1. All the way around. Okay? So a unit circle has a radius of 1. And then we also have different degree measures. This could be 30 degrees. Not could be, it is. And then this one will be 60 degrees. And then we know what this is. That's a right angle. Right inside of there. And if we kept going, well, we know that from here to here would also be 30 degrees. Well, 30 plus 90 is 120 degrees. And if we go all the way around, we already talked about that, that's 360 degrees. Well, what a radian is it wants to know what the distance is of our circumference of a unit circle. So, if I want to know what the radians are of my full circle, well, it's 360 degrees, my full circle. To find the circumference, which is what radians are, radians equals circumference of unit circle. So from here, around here. So how do you find the circumference of a circle? Well, if you remember, circumference, perimeter, or circumference, is equal to 2 times pi times r. That's the equation you probably learned back in middle school, or if not before that. Well, our r in this problem, we've already talked about, is 1. So really, the r just kind of goes away. It's 2 times pi times 1, which doesn't affect our equation at all. So the radians of a unit circle of 360 degrees would be equal to 2 pi. So once again, radians is just the distance of the circumference. Well, if I'm saying 360 degrees, that means you start here and you go all the way around. So the circumference of a unit circle is 2 pi. Well, if I said, what are the radians of, let's say, half a circle of 180 degrees? Well, if 360 is 2 pi, that must mean that half of that would be 1 pi. So the radians of 180 degrees would be exactly 1 pi. Now, there's a way to go back and forth on this pretty easily. So if I said, what's the question of 30 degrees? So the radians of 30 degrees, what you'll do is you'll take the equation. It's going to be pi over 180 or 180 over pi. These are the two different ways you can go back and forth. So if we want a radians, we're always going to have a pi in our radians, which means that we're going to want to choose this one because that one's going to add a pi. So 30 pi over 180. And we can make that a big fraction. We can cross off these zeros, so we get 3 pi over 18. And 3 and 18 can both be divided by 3, so we get pi over 6. So the radians of 30 degrees is equal to pi over 6. Okay, now if I said, let's go the other way. Let's say I had pi over 6 radians, and I want to know what the degrees are. Well, I would do pi over 6, and we're going to use the other one. This is to go to degrees. This will be 180 over pi. And you know that because the pi's are going to divide out. If I multiply by 180 over pi, these pi's will cross out. And I'm left with 180 over 6. And 180 over 6 is equal to 30. Okay, so let's look at a question now on con. So they're saying convert the angle theta, which is equal to 8 pi over 9, from radians to degrees. So 8 pi over 9. Now, when we're trying to get rid of a pi, we have to multiply by something over pi. So it'd be that one, 180 over pi. Well, the pi's cross off, which is what we want to happen, because we're trying to go to degrees. So we're going to have no pi's in our degrees. And then 8 times 180 is 8 times 180. We get 1440 all over 9. Let's see if 1440 over 9 is an answer. And we get 160 exactly. So the answer for the first question would be 160 degrees. Okay, next question. All right, so we're going from degrees to radians. We have 100 degrees. And we want to know the radians. So this time we want to have a pi in our answer. So we're going to be multiplying by pi over 180. Well, the first thing I want to do is 100 times pi over 180. Well, we can cross these zeros off. So we get 10 over 18 pi. Or 10 pi over 18. And both of these are even, so we can divide both of them by 2. So we get 5 over 9, and our pi is still there. So 5 times pi over 9. And you can see your pi button is right down here, so hit that. And then we're going to hit divide by 9. And our answer is right. Third question. So 3 pi over 5. And we're trying to go, we have radians, so we must go to degrees. Once again, we have a pi in the numerator, so we're going to do the one with our pi in the denominator. I wrote this one down incorrectly, but you can see that if we do 3 pi times pi, we're going to get 3 pi squared over a number. We don't want pi in degrees, so we know that one's wrong, okay? So if you do make a mistake, you can tell right away that you made a mistake. Then fix it. Now, we can see our pi's cancel out, which is what we want in degrees. So 3 times 180, or you can just do 180 divided by 5. 180 divided by 5, which is 36. So we would have 3 times 36, which is equal to 108. If you don't like, or if you don't understand how to do my math there, you can also do it the other way. You just do 3 times 180, which would be 3 times 180, and then divide by 5. And you get the same answer. It's still 108. I just did 180 divided by 5 first, and then times 3. Oops, 108 is our answer. Last question. Probably going to go to 2 radians this time. Yep, 345, 2 radians. So this time we want to add a pi. So let's say I do it the wrong way again. If I'm not sure, I would do it like this. And I want to go to radians. Well, I'm going to have a pi in my answer, but that pi is going to be in my denominator. And that's not going to be right. We want it to be up and top. So this is done wrong. And so now we can figure out degrees to radians. So we get 345 pi over 180. Now, how to simplify this? We can't pull a 10 out, but I know I can pull a 5 out. So I'm going to divide both by 5 right away and see what we end up with. 345 divided by 5, we get 69 pi. And 180 over 5 we just did was 36. Okay, so looking at both of these, I'm pretty sure I can pull a 3 out of both these things. So I'm going to divide 36 by 3. I get 12 in the bottom. And 69 divided by 3, I get 23. And 23 is a prime number. Oops, you can't see that. 23 is a prime number, so we are done. So 23 pi over 12 is our answer. And right.